Hello geometry students, this is Miss Doolittle. So this video is going to walk us through everything that they needed us to talk about for the parallelograms lesson and therefore get you ready for that quiz. So again, I'm going to try to keep this as brief as possible. Anytime that you need to pause the video, if you want to jot down some notes, feel free to do that, but I'm going to go through this as quickly as possible to respect your time. All right, so to start with, in Euclidean geometry, which is the specific type of geometry that we are studying in this course, a parallelogram is a simple quadrilateral, and of course you guys know that a quadrilateral means a four-sided figure, and it is also made up of straight sides. So a parallelogram, though, is a simple quadrilateral with two pairs of parallel sides. So that means opposite sides are going to be parallel. So if I look at my diagram, remember these arrows represent that those are parallel lines. They are never going to intersect. Now the other sides are parallel as well because it says that we have two sets of parallel sides. So I'm going to label that with that double arrow. So now the single arrow sides, the top and the bottom, we can see that those are parallel. And the double arrow sides, the right and the left, we can see that those are parallel. Now, another thing that we can see is that the opposite or facing sides of a parallelogram are of equal length. Okay, so in other words, opposite sides are equal. Opposite sides are the same. We're also seeing that opposite angles of a parallelogram are equal. Okay, so what I did down here is just make a list of some of the characteristics of parallelograms. I kind of pulled that out of that paragraph form of the definition. So characteristics of a parallelogram. It's made up of four straight lines. It's quadrilateral. Opposite angles are congruent. Here's what that means if we look at it on the diagram. This angle and its opposite angle are the same measure. But then I have another set of opposite angles, and I'm going to mark that with double arcs so that we can match those up. So this set of angles is congruent as well, okay? Opposite sides are congruent, so that means this side is the same length as this side, and this side is the same length as this side. Okay, and of course opposite sides are parallel, and we've already talked about that. So again, if you want to get this down in your notes, feel free to press pause now. Okay, so one of the things that your lesson refers to is a square a parallelogram? And this really just goes back to the definition of it. What I did is I copied and pasted those characteristics from the previous slide right here. So remember, the characteristics of a parallelogram are it's made up of four straight sides. Is that the case with a square? Clearly it is. In a square, are opposite angles congruent? Well, in a square, we know that all of them are 90 degrees. So are my opposite angles congruent? Absolutely. In this diagonal as well, those opposite angles are congruent. So we've met this characteristic, we've met this characteristic. Now, are opposite sides congruent? Absolutely. These two are congruent to one another. Now, what about these guys? Because in a square, of course, all of them are the same side length, or same length. So these side lengths across here are congruent as well. Yes, it is true that all four of them are congruent to each other, but when we're talking about meeting that definition, my opposite sides are absolutely congruent. They are the same. And now, are my opposite sides parallel? Yes, most definitely. And then these guys are parallel with each other as well. So that means, yes, a square is a parallelogram. Okay, now we could go through the same type of thing for a rectangle. Is a rectangle a parallelogram? You're going to find out in the same manner that we did on the last slide. Yes, it is most definitely a parallelogram. My opposite angles are equal because by definition, I have all 90-degree angles in a rectangle, right? So opposite angles are congruent. It's made up of four straight lines. It's quadrilateral. Opposite sides are congruent. So we meet that definition. And opposite sides are parallel. So we meet that definition as well. So a rectangle, just like a square, is simply a special kind of a parallelogram. A special kind of a parallelogram in that they have all 90-degree angles. And then of course with a square is a special kind of parallelogram where we have all 90-degree angles and all of our sides happen to be congruent. Okay, now, I just did a video earlier on parallel lines cut by a transversal. And so if you guys are unfamiliar with parallel lines being cut by a transversal, I really recommend that you go back and watch that. In the case that you feel that you don't need to watch that because you understand this relatively well, I just went ahead and put the information in this slide. So if you'd like to pause the video and jot this information down, feel free to do that. If you start taking a look at this information and you decide that you really don't understand it as much as you thought you did, please go back to that other video and take a look at that because I explain all of it in here. I'm not going to explain it, or in that video. I'm not going to explain it at this point in time out of respect for time so that we can move on and make this video as short as we can. Okay, now, here's what happens in the lesson in Accelerate. What they're going to do is extend the side lengths of a parallelogram. So here's the idea. What they want you to see is that these two lines are parallel and that these two lines are also parallel. Okay, so what actually makes your parallelogram, I'm going to put vertices on those points for the parallelogram. So we're talking about parallelogram A, B, C, D. And they just want you to be able to visually see the parallelogram within, and it kind of looks like a tipped over tic-tac-toe board, right? But there's two sets of parallel lines there. And they are going to start really diving into angle relationships. Okay, so I went in and put in all of the angle relationships that would develop out of the idea of these parallel lines being cut by transversals. Because really that's what this diagram is, right? If we have these two parallel lines, we can think about it being cut by the transversal MN, and also being cut by the transversal JK. Okay, and it just so happens that those two parallel lines, those two transversals are also parallel lines. So I've highlighted the vertices of our actual parallelogram so you can spot that because this is a pretty busy diagram right now. But based on the angle relationships that came out of the parallel lines cut by a transversal video, I'm just going to flash back to what I had a couple slides ago real quick. Here are parallel lines cut by one transversal, and now we're expanding that to parallel lines cut by two transversals, but all of those angle relationships are going to hold, okay? So we're talking about angles 1 and 7 being vertical angles, and 3 and 5 being vertical angles, and 11 and 16 and 9 and 14 and so on and so forth, okay? Angles 2 and 10 are what we call corresponding angles. 7 and 14 are corresponding angles. 4 and 12, 3 and 11, all kinds of sets of corresponding angles within this diagram. Again, if these are pieces that seem a little bit confusing to you, it could be that you don't really have a good solid understanding of those parallel lines cut by a single transversal, and you need to go back and take a look at that review video. Okay, so at any rate, I wanted to show you this so you can see. I could spend 20 minutes just re-going over these angle relationships, but if you understand what those are when you have parallel lines cut by a transversal, this should seem pretty reasonable, right? So remember, the same colored angles are congruent, and the different colored angles in these cases are going to be supplementary. They're going to add up to be 180 degrees. One of the things I want to point out, specifically within our parallelogram, right? Inside this parallelogram, you can see my opposite angles are congruent. They are going to be the same. That is the case with angles 7 and 11. That's also the case with angles 6 and 10. Okay, and then of course we also have relationships due to vertical angles and alternate interior angles and all kinds of good stuff. we have relationships with some of those exterior angles as well around our parallelogram, okay? All right, now what Accelerate is going to want you to do is take this idea of these angle relationships and make some calculations based on that. So again, if you are trying to get this down on your notes and you want to pause the video, please feel free to do that. Take all the time you need, highlight, make the marks on there, and all that good stuff. And while we're doing that, I'm also going to mark that, because remember, opposite sides of a parallelogram are also the same length. So we want to make sure that we mark that appropriately. Okay, so this brings us to some practice problems that you'll find in Accelerate. In Accelerate, you can go in there and just push these individual buttons. Obviously, on my PowerPoint and in this video, you can't do that. But let's go ahead and see if we can answer these questions. So which angle is vertical to the 60-degree angle, right? So this is 100% purely from that idea of parallel lines being cut by a transversal. So the 60-degree angle and angle B are the ones that are vertical angles. If you'll remember, they share a common vertex, but they do not share a common side. So the 60 and the B are vertical, so that one would be B. Next question that pops up after that, they want to know what is the measure of angle E. Okay, so we know that 60 and B are vertical angles. Vertical angles are congruent. What that means is that angle B is also 60 degrees. Now I'm going to flash back really quickly to that one that had all the color on it, okay? So I want you to think about looking at this angle and then this angle. Those would actually be same side interior angles, right? So that would be the same as like your angle 7 and your angle 10, and you'll see that they're in different colors. So what that means is that those are supplementary angles. So if I were to write this out, I would say that 60 degrees plus angle E is 180 degrees because those are supplementary angles. And then of course you subtract 60 from both sides and we end up with E is 120 degrees. Okay, so this answer choice right here. All right, now they want to know what is the measure of angle D. Well, what we just calculated on the last slide is that angle angle E was 120 degrees, and angles D and E are a linear pair. Therefore, they are supplementary. They add up to be 180 degrees. You could also look at it this way. The 60 that we started with right here, in the very first problem, is a corresponding angle to angle D. And corresponding angles are congruent. Therefore, angle D must be 60 degrees. All right, next one we need to take a look at. This one's dealing with side lengths. So they're telling us the length of segment AB, that's this one up here, is x plus 10. Segment BC is x plus 5, and the perimeter of the parallelogram is 46. Okay, here's what we know. This side and this side are the same length. This side and this side are the same length. And at any point in time, if you want to pause the video and see if you can work this out, you go right ahead. But I'm going to continue with my explanation. So now, if I'm hoping you guys can see this, if the entire perimeter is 46 centimeters, there are two ways you can look at that. You can either, this would be like method number 1, and either way is perfectly fine. I can say that I'm going to have two side lengths of x plus 10, and I'm going to have two side lengths of x plus 5. And I don't have room to write this, but those two, all four of those added together are going to give me my perimeter of 46. So I could do it that way if I chose to. For me personally, I like to try to keep my numbers as small as possible because the smaller the numbers, the less likely I'm going to make some kind of goofy error. So what I'm going to think about doing is say, well, if I'm going from this piece right here, and I think about this side plus this side and get around to this other part right here, that's really half of the perimeter, right? I'm only doing half of the perimeter. Well, half of the perimeter is 23. So then I can say just having x plus 10 plus my side length of x plus 5, if I can squish that in there, is going to be 23. And then you can work that out from there. And I don't know about you guys, but I came up with an x value of 4 in that particular situation. Okay, and this is the last slide. One of the last pages in your lesson talks about creating a parallelogram, and I just thought this was noteworthy. It's kind of cool. I'm not going to be able to do this in an exact manner like we should do in geometry, but just to demonstrate, I want to show you what happens. So if I were to take any quadrilateral, here's what the page tells you in Accelerate, is if you take any quadrilateral, there doesn't have to be any rhyme or reason to it, just any quadrilateral at all, and you go to the midpoint of each of the 4 sides. So I'm going to try to mark those, and I would recommend that you try this on your paper. Okay, actually draw out at whatever kind. It does have to be made of 4 straight sides, but there doesn't have to be any uniformity to your angle measures or to your side lengths. So make it real kind of strange and wonky looking, sort of like this one is. Then you go to the midpoint, mark the midpoint of each side. And now what I'm going to do is connect all of those midpoints. I'm going to make lines out of those, and keep in mind I'm probably going to be off at least a little bit here because we are not working with super precise tools. But you see how those lines kind of match up there? And then I'm going to insert another line here to here, paste it, and sure enough, that should be able to fit over on this other side. And of course, it's going to make a liar out of me now, but that's probably because my midpoints are off a little bit. But what should happen if I were working with more precise tools is if you take any quadrilateral and you join the midpoints of all of the sides, it should result in a parallelogram. There are mathematical proofs behind that, so that should happen all the time. So my midpoints have to be off a little bit because I wasn't able to measure, and that's the reason that my parallelogram, I've got this one vertex down here that didn't match up perfectly. But from a mathematical perspective, that is a way to construct or create a parallelogram. Okay, so that pretty much wraps it up. So see how you guys do on the quiz after this, and if you have any questions, as always, make sure you reach out and let me know. Thank you for watching. Bye-bye.